So we printed a module. This is going to be for an 18 volt battery, 5 cells. So 5 times 3.7 is approximately 18 volts. And it's a Ryobi top of an old Ryobi battery. And what we're going to be doing is filling this up, putting wires on it, and yeah, pretty much just screwing it or fixing it to yes on that. We haven't figured that out yet. So it'll be a new battery module, around 10 ampere hours, using these cells. They're around 2400, so 9600 ampere hours. Anyway, so here's the drawing of actually what we'll be doing. So basically what we've got is a bunch of these cells. Now this drawing, these blocks represent each sort of cell block of cells. So basically we could if I'm just looking at the first one, it's just going to be a group of 2 of these pairs. It's probably more accurate if I represent it that way. So 1, 2, 3, 4, 1, 2, 3, 4, all in parallel. So we're going to be basically linking these together with a wire.
Yeah.
And that'll multiply out the current that's going through there. So you've got each one of these is 2400 milliampere hours, the cells. So they add together when you put these, when you link these in parallel. So 24 plus 24 plus 24 plus 24, which is 9600, 9.6 ampere hours. If you multiply it by the voltage, 3.7, then you get your watt hours. So that's basically what we're going to do, and we're going to do that for all five blocks, and then we're going to solder on a little wire. So this is what we call a balance cable. So we're going to solder a balance cable on, and I'll just do 2 blocks so you can see how the balance cable works. Let's put two blocks together. So we're going to connect them in parallel, and then we're going to connect these two in series. So that becomes one battery, and that becomes a battery, or a cell in the battery, I should say cell. That becomes one cell, and then we put them in series, and when you put batteries in series, their voltages add together. So hence we've got 3.7 plus 3.7 plus 3.7 plus 3.7 plus 3.7 equals 18 approx there. So that's how it works. So then later on, these are lithiums and they don't self-balance. So what we've got to do is put a balance cable on it. You can order these on eBay. And basically what all this is, we use this with those little blue RC chargers. We'll show that later in the video. So that plugs into the balance charger. And then these wires will get soldered on. Basically these wires are going to sense the voltage on each cell. So the red wire will go on here, black wire on next black wire. Let's chop it off and give you a show. So I'll just snip that connector off and use that. Leave it like that. So if we looked at the first 3 wires, 6 wires in total. So red's going to go on there, black's going to go on there, and the next black's going to go on the back of that one. So what that does, the charger can measure. The charger's going to can sense and measure the voltage on each cell.
Yes, yeah.
Now, and it'll balance them when we do a balanced charge. So if one cell is too low, the voltage is lower than the others. It'll push more current into that one and less into the others. You know what I mean? So it'll auto-tune the battery. It'll just balance them. And it'll take them all the way up to 4.2 volts, or 4.1 in our case. We don't want to stress the cells out, so we take it to always 4.1, not 4.2. You'll double the life cycle life of the batteries. Yeah. Another thing with the lithiums too, if you haven't heard, don't leave them charged. Don't store them charged. If you're putting a lithium battery in a shelf for a couple of weeks or months, never keep it fully charged. You wreck it.
Okay.
So always aim for its sort of nominal voltage, which in this case would be 3.7. And the little chargers, I don't know if you've noticed, have you ever looked at, there's a storage charge?
Yeah.
You've seen the storage charge? Yeah. So what the storage charge does, it actually just discharges them all down to 3.7 volts. That's what it does. And if you store it at 3.7, they'll last a good 10, 20 years, you know, if you're just storing them. But you've got to top them up every couple of years, because they self-discharge a little bit. But yeah, so never keep them. If you keep them fully charged, you only probably get about 2 to 3 years out of a lithium battery. if you keep them around 3.7, you get a good 10, at least 10, 15 years out of them.
Mm-hmm.
You know? And again, if you're charging them to 4.2, you only get probably 200 to 400 cycles out of it. If you charge them 4.1, you get 400 to 800 cycles out of them. So it's a good way to get them to last longer. Anyway, enough dribbling on. So here we go. So we've got our picture here. We're going to follow the picture. We're going to put this cable on later on. So we're going to test these batteries, put them in here, link them all up with some wire, and then put the balance cable on, and also a charge cable, which I haven't shown you yet. It's a little Dean's connector, and you know the little RC charger uses those. So the charge, it'll plug into here. Now, most of the current will go through here, these two wires, and the balancing will happen through these. Anyway, let's get started. So, first step, we're going to measure the voltage on these to make sure these are right. These have been tested, these batteries, so they've been charged and tested. But what we've found is some of them have actually got internal shorts, and what that means is they've actually discharged themselves over time. And we've just got to check that none of these have done that. So grab yourself a multimeter and just measure each one. They should be over 4 volts. If they're not, then they're a bit iffy. Because they've been sitting around for a couple of months. I'll put it right shot. So, turn it that way for the camera. So it's actually not fair on you guys. I'll turn it that way. The guys on. This is awkward. Anyway, so the guys watching the video will have to turn their heads over. So, you guys know the metal casing is always negative, and the insulated end is always positive here. So black's negative, red's positive. Doesn't matter if you get it one way. 3.7
negative on the multimeter anyway.
Yeah, it'll actually just tell you it's negative. So negative 3.7 when I do that. So anyway, that's already quite low, but I'll just since it's only for a drill battery, we'll just let it go. 3.8, they're all going to be sort of a bit lower. That one's way too low, so that's 1.3. So yeah, we chuck that aside, and we're going to what we do is put just a red X on each side, so we know not to use it. So we're not going to try and charge that one again. It's a failed battery. It's never going to get used for anything. We'll just go to recycle. 3.8, 3.8, 1.6, another dead one. 1.4, another dead one. 3.7, 3.7, 4.1, that's a good one. That's the best one in there. 4.1, two really good ones. And we'll need 2 more pairs. So we're using the same, another thing to make sure when you're building a pack, use the same batteries with the same current ratings as well. So all these have been tested to 3 amp. These are good for 3 amp. So you grab yourself another 2 batteries, the same brand, you don't try and mix batteries. 3.9, 4.1, yeah, that's good. So there we go, we've got our batteries sorted out. So then we can just start. Now next step, we've just got to prep the ends for soldering. Most of them are already done. You can see I hold it. It's too much light. Yeah. But these have already been pre-ground with a Dremel. So we use a Dremel just to clean up the ends so we can solder onto it. That one's okay. That one hasn't been done. If you look at it, it's covered in plastic. So get your Dremel out. Cool, so we've got 10 pairs all sorted out. Now there's one more step we've got to do. So grab a bunch of old business cards, or whatever sort of thin cardboard you got lying around, or an old stiff magazine paper is really good. You can use paper if you don't have anything else, but you have to fold it like 20 times to get thickness up. And I'm just going to grab some tools. So one of the things with these batteries is they have a tendency to short out when they overheat. So what I like to do, especially when we're soldering in the middle here, we never solder on the ends. Really important, because they'll start boiling. The internal gases will boil and they'll start venting, and it's a flammable. There's like a hydrocarbon, like a petrol type substance in it. Not a good thing to once it starts vaporizing. I've got a heat source on.
Dangerous.
Yeah, so don't ever solder on here, and even when you're soldering here, try and solder as quickly as possible, really quick. So high heat, real quick soldering. Don't take your time. These are a little bit more forgiving at this end, but yeah, this is the sensitive end, the positive end. And carefully when you're doing this, you don't want to really ram the screwdriver in here. So I just pull. I just put it in the middle and pull up, and then just make a bit of a, just raise it up a little bit, so we can just force some cardboard under there. Because you'll find, see under this plastic here, it's actually the negative side, so there's very little insulation in between the positive and negative, and it melts quite easily. So if there's something goes wrong here, it tends to melt. So I like to use cardboard because it's even if it gets really hot, it chars a bit, but it doesn't melt through and short everything out. So get a bit of cardboard and just cut a strip off, probably about 5 mils, 6 mils wide. Cut a little strip, fold it, and probably fold it once more, and just see if you can force it under. Maybe it's a bit thick, so I'll just fold it once. Just fold it like that, and just shove it under there. And then just snip off the excess. So that cell's ready to go into the module now. So just pick an end to start with, just poke it in there, and then do the next one. And what we're going to do, we're going to put them, we'll see when we do it, but that'll go that way, and then the next one will go the other way, because then we link across there. And this, of course, the same for that one. And these are the same. So two that way, two up, two down, two up, two down. And then we just link across on both sides and we're done. And then get your 18 volts. So we'll just prep that down. You can see that's quite damaged, this one. So we're going to make sure we get this one right. So that'll protect it. Nice snug fit so they won't fall out. We haven't cleaned them up, so they've got a lot of glue and stuff on the outside, and that's why they're a bit tight fitting here. So we don't bother, obviously we don't need to do it on this end, because you're negative against the negative can. You don't, if that shorts to that, it doesn't matter. It's the same, it's welded to it anyway. It's just at the same potential. But this one's, you've got all the, you've got plus and minus, just basically a fraction of a millimetre apart. It's a bit more sensitive. So that's it. So pack's been populated with the batteries, up, down, up, down, up. Now I can start prepping the wire for it. We've pre-prepared some thick wire. This is our mains wiring. So stick with the colour. I'll take the red one. Doesn't matter what colour you use. So this is probably 20 amp, 25 amp wire.
And if it's lighting, it's normally 10.
Could just be 10, yeah. I hope it's, yeah, it could be. It looks pretty light. I don't think it's more than 10. So it's a little bit light for this. I would have liked to use 20, but...
And you need power circuit cable.
Yeah, ideally we should have used a thicker wire. So what we're going to do is, basically you need to link this way, and we need to link this way as well. So that becomes one,
Okay.
you know what I mean? We're just basically doing this linking here. So we're linking these two together. You know what I mean? That'll become our negative, these two. That's the link in between. So these four, see these 4 link points? 1, 2, 3, 4. 1, 2, 3, 4. So I'll just strip it back so the wire can reach over these two, can bridge over these two. Twist it up. It's pretty good. use along those pliers to make a nice bend. And then we're going to come out about to there. And I'll just put a notch in there so I can see it. And then I'll cut the wire. And strip it back. That's too many, isn't it? That's about right. So soldering iron, we're going to run a nice 450, really high. So this one will go to 500. Or we'll just turn it back to 450. Because what we're going to do is just do it really quick as possible. You don't want to spend too much time on each point because the heat will conduct through into the tops of those. So again, just for safety. So we'll clamp it like that. I'll do that one and then swap it over to the other side. Just turn it up. Cool off, and just tin up the ends on our batteries. So I usually just put a decent sized blob on there. And be really careful where you hold the solder. Always try and come. Yeah, because you can actually just short it and it'll just blow the solder. I've done that plenty of times, so don't feel bad if you do it, because it happens all the time to me.
At least it's solder. It could be wire, and then you'll get
exactly.
real buzz.
So just start at one end. So yeah, just try and heat both evenly, and again, don't spend too much time on it. When you're holding it with your fingers, you don't have much time before the heat gets to your finger. But you can hold it with something like this, so you don't burn your fingers. So probably don't do what I just did. That's the first one done. So flip it over, and now be really careful. You're not going to link these four. You know what's going to happen if we link those four. You're going to either melt these or something else is going to blow on it. Worst case scenario, one of the batteries will rupture. So again, we'll just tin everything up. And careful not to bridge it now. So if you bridged it now, it would actually go off. Because now these are live. I mean, there's 7.4 volts across here, these two terminals. And then crap load of current. Forgot to tin up the other two, because that's going to be our negative of the whole pack. So we're going to bridge these ones. So we finish that one, and now we're doing this one here. So just double check it so you can see the electricity flows. You know, this flows from here to here, across, and then from here to here, and then across again. So it's doing like a zigzag through the pack. So flip it over, and we go do the next bit here. we'll do the charge cable. Actually, you've got to have two wires come off it. One to go to the drill, and then one to the balance cable. So that's it. Now we can test it. We can measure. It should be able to measure 18 volts through that, or above, probably 19 volts or whatever it's going to be, close to 20. So negative and positive. So 19.56. So we're good. This is a good pack. So that's all. At least that part's done correctly. So now we're going to put the balance cable on. You don't need to strip them back very far. Maybe a little short, a little bit. Let's turn them up. And careful when you put this down on something. Don't put it on anything metal. Do you imagine what's going to happen?
It's going to be fun.
So grab your other wire that we're going to use for the Dean's connector, and I'll just grab brown and blue. Make them the same length, because we're going to cable tie them up and it'll just come out like a bunch all together, so you know it's for the balance cable. And then we'll bring another bunch of cables out for the actual power. But we won't solder those on because we solder them into the drill first and then bring the wires onto here, because you don't have dangling live wires off your pack. You know?
Yeah,
It's a safety thing. So you bring the drill wires out and then put them on here. That's the heavy stuff done. So now we'll just do the Dean's connector. And again, start with the connector end. The last thing you do is solder it onto the battery. Don't ever do it the other way around, because you'll end up shorting it out. So never solder live stuff, like connectors with live stuff. Blue is negative, brown is positive. Turn up your connector. So the leg running in line with the connector is negative, and the leg running perpendicular and up and down to the connector is positive. Heat shrink. So now we can safely solder it on. So choose one end for the, I usually do one end, and then the main one off the centre. Negative, positive. So that's on. So we've got to decide which way it's going to come out, probably that side, that's the way it's laying. So I'll do the red. So now we're going to do the balance cable. So that's our charge cable that goes into a little RC charger. And we grab our balance cable, start at positive. Doesn't matter which end you start at. Take the next wire. So make sure you get the sequence right. So take the next wire in the connector. Just work your way along. Flip it over, and if you can, always solder onto the negative side of the battery. It's safer. Then flip it over again to the next leg, staying on the negative. So flip it over again. Just see we're just working our way along. And that's it. And we'll just cable tie it up. So I usually just, what I do is work from this end back when I'm cable tying. Have it come off one end. So just hold it together. Just put one around here. So give yourself enough length to plug it into the charger. Something like that, and then to sort of work out where your wires are going to hang off. So split them into two groups, top and bottom. Put one more on here until we get close to the pack. Yeah. Don't be too fussy because we'll put something over this to cover it. So here we are, we're just going to charge this battery now. Just finished wiring it up yesterday actually. So let's plug it in. We had some problems with this connector, which I've never seen before. It took us a while to figure it out. So Dean's connector, plug that in. Make sure you get polarity right on here. Now this will only go in one way, so there's a little 5S charging port there. We'll just plug it in there. And what we usually do is do a LiPo, which charges to 4.1 volts, which puts less stress on the batteries because they're going to 4.2 volts is not really good for them. It halves their life cycles. So we're going to go to balance. We're going to do a balance charge, 1.5 amps and 18 volt, 5S. Hit enter, battery check, confirm, and it's away. And we can just see the voltage on all the cells there. So it's going to take a while to do this one because it's out of balance. It's the first charge. So you can see the first cell is at 4.13 and the others are quite a bit lower. And they'll take ages to come up, probably a good couple of hours. And the charge current's going to be really low. It's pretty much zero. And that's it. And once that's done, we'll solder it into the drill. So here we are, the last step. We're just going to put a couple of wires on the battery pack now. This is an adapter for a Ryobi 18 volt. It's a standard 1 Plus series. It's an old NiCad pack. We've just taken the top off and I just printed up an adapter module. And yeah, so we're just going to strip some wires. Put the 12 volts on. Sorry, 18 volt plus. So that side's done, flip it over, let's do the negative. And this one will just join on the middle. And that's pretty much done. We'll still put some side covers on it, but that's pretty much it. So Ryobi 18 volt, 10 amp per hour. It's a lot bigger than what you can buy. I think the biggest you can buy is 5 at Bunnings, and I'll just get a drill to test it. So just plug it in, and it's got plenty of beef in it. It's good to go. I'm just going to put a strap around here to keep it from falling out when you're using it. And you can leave it on there and you can just charge it while it's on there, so you don't need to take it out again unless you're changing tools. And that's pretty much it. So one battery module done.